Good morning, students. Today we will study the exact formula for maximum velocity along the bank road. Students, if I observe in practice, vehicle never travel exactly with this speed. With speed, v equals to under root of rg tan theta. Students, always remember, because in the last lecture we ignored the frictional force and the air resistance force. Air resistance, let us we can consider we can ignore, but frictional force we can't ignore, because though maximum limit of the velocity along the bank road is what under root of rg tan theta, but no vehicle will go with that particular speed. That speed limit will be either less than this root of rg tan theta or greater than root rg tan theta. So students, we are going to consider two cases, lower speed limit and upper speed limit. So students, let us understand the first diagram. We will do both the derivations simultaneously. For lower speed, when speed is low, then we observe that this vehicle is trying to move towards the center of the curvature. It is moving. When it moves like this, then friction force will be opposite to that particular movement. You can see Fs is a frictional force along the bank road. And when speed is what? Very high, more than that rg tan theta, it moves like this, vehicle is trying to move like this, then friction force will provide necessary centrifugal force, which is what? Along this horizontal way. So when it is lower speed, the direction of the frictional force is what? In this particular direction. And when it is upper speed, direction of frictional force will be in this direction. So we observe that this frictional force makes an angle of theta with the horizontal surface. And here also Fs makes an angle of theta with the horizontal surface. So we will resolve this particular frictional force into horizontal component and vertical component. So remember students, horizontal component is what? Fs cos theta, which is in the right hand side direction, towards the right hand side, and Fs sin theta is what? In a vertical direction, upward direction. For this case, students, if I resolve this frictional force into two components, so Fs cos theta is in the horizontal direction, but it is what? Towards left, and Fs sin theta is in vertical, but it is downward. But only we have to remember both the things. So students, if I observe vertical forces, so which vertical forces acting on this particular lower speed limit system? N cos theta, Fs sin theta, and what? Mg. Since N cos theta and Fs sin theta is in vertical direction, upward direction, so we are going to add this particular two forces, and Mg is in downward direction, which is vertical, but it is downward direction. We are going to subtract. Okay, so N cos theta plus Fs sin theta is equals to what? Balanced by weight mg. So students, we observe that from this particular equation, mg equals to N cos theta plus Fs. Students, I have written here what is Fs is given by coefficient of static friction multiplied by N. So when I add Fs sin theta, in place of Fs I am going to write mu s N sin theta. So here we have written, you can observe here, mg is balanced by N cos theta plus mu s multiplied by normal reaction multiplied by sin theta. Similarly, for the higher speed, we observe here N cos theta is in vertical direction, F sin theta and mg both are in the downward direction. So students, from the diagram we can write mg first. What is horizontal components of Fs? As I told you here, let me write here Fs cos theta, and here Fs sin theta. From the diagram, here mg is given by N cos theta, which is in the upward direction, and F sin theta is what? Is minus, because it is downward direction. In Fs, I am going to write mu s multiplied by N into what? Sin theta. So students, we got vertical forces equation for both the cases. Okay. Simultaneously, I am solving. So what? It will be easy. Students, what is the horizontal component here? Fs and here also horizontal component is what? Fs. Sorry, it is along the horizontal road, but horizontal component here what? Fs cos theta, and here is what? It is also Fs cos theta. It is in right hand side direction. This Fs cos theta and this n sin theta is in the opposite direction. Since it is a horizontal component, we know that horizontal component provide necessary centripetal force. Students, remember, horizontal component always provides necessary centripetal force. So students, here I am going to write n sin theta minus Fs cos theta. Sorry, n sin theta minus Fs cos theta. In place of Fs, I am going to write mu s multiplied by n cos theta, and which will provide one necessary centripetal force. Okay, the necessary centripetal force will be in this particular direction towards the center. Okay, so n cos sin theta is equals to, you can see here, n sin theta minus mu s n cos theta, which will provide necessary centripetal force, which is mv square upon r. Okay, similarly for this upper speed limit, I can write n sin theta plus Fs cos theta, but Fs, in place of Fs I am going to write mu s n multiplied by cos theta, and which will provide what? Necessary centripetal force, which is what? mv1 square upon r. Simultaneously I am performing both the equation, both the solution or both the derivation, so that you can easily remember. Now 2 divided by 1. So what is the left hand side of this equation number 2? mv1 square upon r upon mg. What is the right hand side of the equation number 2? N sin theta minus mu s n cos theta upon n cos theta plus mu s n sin theta. We observe that here, and if I take common, and if I take common, it get cancelled. The remaining terms are what? And one more thing, students, we observe here, get cancelled. So what are remaining terms, students? v1 square upon rg sin theta minus mu s cos theta upon cos theta plus mu s sin theta. Students, in the right hand side, we will do one more thing. Divide numerator and denominator by cos theta. So we observe that if I divide sin theta by cos theta, we will get what? Tan theta. If I divide cos theta by cos theta, we will get what? 1. Here also 1, here tan theta. So what will come here? Tan theta minus mu s here plus upon 1 plus mu s tan theta. And I will shifted this rg towards right hand side. And if I take the square root, I will get rg under root of rg bracket tan theta minus mu s upon 1 plus mu s tan. Same thing we will apply in the right hand side. So students, we will apply here. You can observe over here mv1 square upon r upon mg. What right hand side here, students? N sin theta plus mu s into n cos theta of the equation number 2. And what is right hand side of the equation number 1? N cos theta minus mu s n sin theta. So students, same thing we are going to do here. N get cancelled, get cancelled. Then we will write like this: v1 square upon rg is what? Sin theta plus mu s into cos theta upon cos theta minus mu s into sin theta. In the right hand side, we observe that divide numerator and denominator by cos theta. Same procedure we are going to apply here. So rg, what sin upon cos here, students? Tan theta plus cos get cancelled, mu s the whole divided by here 1 minus mu s into tan theta. And if I take the square root, so rg tan theta plus mu s upon 1 minus mu s into tan. This is a formula when frictional force are going to be considered and when speed limit is either less than that particular value, the root of rg tan theta, or greater than root of rg tan theta. Now let us do the numerical, students. Simple numerical is there. We will finish numerical within 2-3 minutes. So that what? Our lecture will be finished. Racing track of curvature 9.9 centimeter. So radius of the curvature is given, student, 9.9 meter. Is banked at. So students, this information is what? Theta. So theta is given tan inverse of 0.5. So from this particular equation, we can write tan theta equals to what? 0.5. Coefficient of static friction is given. How much it is, students? 0.2. We have to find a speed of limit. We have to find what? V1. So students, with 10% margin, one more question is that determine the speed of limit with the 10% margin. 10% margin will be either plus or minus. Okay, and G is given 10 meter per second square. Normally, speed limit is always be less than. Okay, so students, we will apply both the formula for V minimum and V max. Okay, that lift speed limit we already did over here. So we will put the values of RG. What is RG here, students? R is what? 9.9. G is how much here? 10. Tan theta value is 0.5 minus mu s is what? 0.2 upon 1 plus 0.5 into 0.2. So we observe that here, students. Let us solve. 9.9 into 10 is 99. 0.5 minus 0.2 is what? 0.3. And 0.5 into 0.2 is what? 0.01 plus 1, which is 1.0. Students, you can solve easily this particular equation. Try to find out the answer. Similarly, I will put over here the value of this particular equation. 9.9 multiplied by 10 tan theta, that is what? 0.5 plus 0.2 upon 1 minus 0.5 multiplied by 0.2. So students, I am getting here 99 multiplied by 0.7 minus 0. That particular equation. Find out the answer, and once you get the answer of V min, you add that 10%, that is 10 upon 100 of V min, you find out the answer, and here lower than that particular maximum speed, so you have to subtract. Okay, hope so you understood the particular numerical. Find out the answer. Thank you very much.